Hi everyone, welcome to Advantech Inside Studio. I'm Neo. Today we invite Xiao, co-founder of Overview AI, and Young, Chief of Staff, to join us and show us how Vision AI solution transform data to insight. Please say hi to audience.
Cool. Thank you, Neil. Thank you, everyone, for being here. My name is Xiao, co-founder of Overview AI. I am the head of engineering at Overview AI. And what we work on are smart inspection cameras, Edge AI-focused smart inspection cameras meant for manufacturers and factories. So we really focus on the pain point that factories have of, one, improving product quality, two, improving operations, efficiency of operations, and of course, detecting defects so that customers don't have products that are bad. Our goal is pretty simple: make AI, the latest and greatest AI, as easily accessible and reachable to factories and manufacturers in a way that they can use and in enough power for them to raise the quality, their standard of quality. So, we serve customers in a lot of different sectors. We serve customers from automotive, medical devices, electronics, a lot of electric vehicles. So the potential of AI in manufacturing is very broad, in our opinion. And to be able to do this, we leverage the state-of-the-art AI on top of ICAM hardware by Advantech. And we think that this combination really gives us a good cohesive product for customers to use. And on the software side, we focus a lot on making the latest AI technology feel simple. We use transformer models, edge-trained models, edge learning, and all these things help our customers deliver what they really need. And we also have built a lot of our own AI software, what we call the Overview Haystack. And this is a tool that lets customers get a lot of insight and business data into their product. So we've been working with Advantech for a very long time, using the ICAM, and we think it's a great partnership. We think that the combination of the best hardware and the best software is really, really powerful for manufacturers and factories.
Hi everyone, thank you for a warm welcome. It's such an honor to be here today. I'm thrilled to join the Inside Studio and share how Nota AI, in collaboration with Advantech, is transforming the world into smart environments. I'm Seogyung Cho from Nota AI, and we specialize in hardware-aware AI model optimization. So in simple terms, we bridge the gap between the most advanced AI models and the device that the model actually run on. So making sure state-of-the-art AI isn't just a lab demo, but something that can actually be deployed anywhere. Now, let me give you a quick snapshot of what we are doing at Nota AI, what we are working on in Vision AI. First, we built the world's first on-device vision language model, VLM. Unlike traditional systems rely heavily on cloud computing system, we are running VLM entirely on edge devices without requiring any extra hardware or expensive GPUs. It matters because our customers are now able to get AI-driven insights from where the data is generated without any latency or privacy risk or massive bandwidth costs. Second, we are already deployed globally. We have onboarded clients across industries and both domestically and globally, and range from manufacturing lines to roadway systems. And third, we bring real-world learning back into our R&D. Everything we have built has been shaped by what's actually happening on the ground. So we are not building AI just for lab condition, but for real-world environment, so that where hardware constraints are real challenges.
So thank you. Great to have you to share this amazing solution from Vision AI. So Advantech serves the manufacturing industry by offering comprehensive streaming, sensing, computing, and graphics vision system to enable our intelligent device and solution from our partner. So as we know that vision solution and vision application is getting higher adoption rate and is installed in many factory flow. So could you please share us some exactly use case and what's the pain point of the Vision AI? Let's start with Xiao.
In manufacturing, there are a lot of different applications for AI. One of them is visual inspection. That's the one we really focus on at Overview. And that means catching defects early, ensuring factories make consistent products, consistent quality, and also helping operators understand why a defect happened and what to actually do to correct it. So a big part of that, of course, is also traceability, giving factories the ability to go back in time and look at a product, why it failed, in a very visual manner. So, at Overview, we see firsthand that AI is very, very broadly used in the industry. But the real challenge that we've seen over and over again is making AI work every day, consistently and reliably. And this is a problem that I'm sure everyone who's worked with AI has faced. It's very difficult in a highly dynamic environment like a factory to fully trust AI, to fully rely on it, and to fully make sure that it's reliable all the time. So it's easy to get AI to be like 90% accurate, but 90% is not enough in a factory. You really need the last percentage of quality and inspection to really get the results you need. And getting that last 10% of accuracy oftentimes is very, very hard, if not impossible in a lot of cases. And that's where we've seen a lot of AI installations fail and AI projects stuck in proof of concept. As an example, one of our customers in the electronics industry space, they've spent 6 months training a model to inspect electronic connectors. It took a really long time to, 1, collect the data, 2, train the data, 3, deploy it. But in a factory setting, you can imagine, it's a very dynamic setting. So every day there's a new defect type, a new problem that comes up, a new failure mode. This happens daily in every factory. So it makes it very hard for people to trust the AI in a manufacturing environment. So that's a big key pain point that we've seen in factories, how to actually get AI models to be quick and efficient.
Thanks, Xiao. Thanks for your sharing. So I truly believe that the consistent and reliable result for vision AI is crucial and is always the challenge for the manufacturing. Thanks for your sharing. And how about you? How did you think? So Young.
First of all, that's a great question and one we hear a lot. In the past, lots of companies hesitated to adopt AI solution because they came up with heavy upfront costs, not just in money, but in time, talent, and complexity. Conventional computer vision systems were highly dependent on task-specific data sets. Every time a new part or new event or new environment is introduced, you had to start from scratch. First, you collect the new data, retrain the model, and test it and hope it works. This makes scaling AI solutions across real-world environment made extremely difficult and time-consuming. But here's where things are changing. At Nota AI, we are solving this with foundational model, specifically with our own device visual language model, which we call NVA, Nota Vision Agent. Think of it like giving the AI general understanding of visual tasks and a flexible vocabulary to describe them. It allows users to adapt AI model into any environment without collecting thousands of new images every time. For instance, one of our clients in manufacturing used to spend about 6 months to adopt a personal protective equipment detection system for each product line. Variances in equipment such as colors, shapes, and manufacturers cause our customers to collect data every time they need to develop a system. However, using our solution, they're now able to adapt a model within days without requiring a massive data set. Ultimately, our goal is to deliver AI that works effectively in real world, not just in control lab settings. This practicality and adaptability will drive adoption across various industries such as industry and manufacturing, and proving that AI can be both powerful and purpose fit for when built the right way.
Thank you, Su-Yong. Indeed, I think we are not able to build the AI from the scratch. So with the preview model is crucial and very important for the factory. On the other hand, there are lots of variation in the factory. So we need the AI, the vision AI solution is more adaptive. That's very important. So let's move on to more detail about the AI algorithm. So we know that, especially in the COMPUTEX, we know a lot of generative AI or the video language model or the LLM, this big model, or even the transformer model. This model will take a huge computing power. However, let's go back to the edge side. We also need to think about the footprint and the energy and the power consumption. And how did you make the perfect balance between the big and large model and the small form factor at the edge? So let's begin with Xiao, please.
Yeah, I think that's a really good question. It's a question we think about all the time at Overview. We're big believers in using the latest and greatest in AI, and whether that means a transformer model or something else, we do incorporate that into our products. We have transformer models that run at the edge and are trainable at the edge, so customers can train a transformer-based fine-tuned model at the edge if their application is suitable for it. What is really exciting about transformers in our experience, particularly on the edge, is that transformers have a very broad understanding of the world. It has a lot of base information to learn from. So when used for the right application, it gets pretty acceptable accuracy, even with few training data, relatively little training data. However, at the same time, we know that factories don't just need what's new. They also need something that's reliable, trusted, and also performant. So how we kind of balance that on our products is that we also have more traditional vision AI-based models like CNNs, and those can be just as accurate as transformers, but they're much faster in inspection time, also training speed, and just general ease of use. So ultimately, we offer both options, both types of AI models, the latest and greatest, but also the stable and trusted, and customers can kind of use what's suitable for their application. I mentioned Haystack earlier. Haystack is one of our products built into our systems that makes training models a lot more accurate and easier. It's quite literally a visual tool that lets you visualize what the model is thinking inside the model. So models, a lot of the time, they're black boxes. You don't really know how it's making its decision. You don't know why it made a decision that way. But with our Haystack tool, you're able to really see why the model made a decision, why it thought it was bad or good. And in our experience with some tooling around the core AI, you're able to save up to 10 times the amount of time to get a model into production. And lastly, of course, no matter how good the core AI is, it has to be combined with the easy-to-use interface so people can actually use it and actually put it into the field. So we build everything in a very easy-to-use interface. It's all on the camera. Everything's on the edge. Training the model is on the edge. Configuring it is on the edge. So it's a very simple way that we balance these trade-offs. We like to say that with Overview products, a high school intern can train a model within 10 minutes. That's really a philosophy that kind of guides our core product development. And we think that ultimately AI should make our lives easier, not harder.
Thank you, Xiao. Indeed, I think that's the domain focus or the application-specific AI model is the way that to make the balance between the large language model and the real case at the edge. Thanks for the sharing. And how did you think about in the workplace from Nota AI point of view? So, please.
So that's actually a quick question. As AI models become more powerful, they are becoming more demanding in terms of computing resources. At Nota AI, we don't just build AI solutions. We focus on hardware-aware AI model optimization. So, which means that we are trying to bring all the state-of-the-art cutting-edge AI models into the local edge devices so that everyone can benefit from AIs. To do that, we stick to three core principles. First, we pursue efficiency without compromising accuracy. We use our own proprietary model optimization techniques such as pruning and quantizations to shrink a model up to by more than 80%. This allows us to deploy AI models, cutting-edge models, onto the local-edge devices ranging from NVIDIA Jetsons to ARM Cortex-based systems. Second, we focus on automation. We've developed a platform called Nespresso, which streams the entire pipeline from training a model to optimizing and deploying the model to the target hardware. We also have built a system called Device Farm with dozens of actual devices. It allows users to test and fine-tune the AI models on the actual hardware that will actually run on, so that it makes sure the models will not only work in theory, but also in practice. Third, we deeply care about ease of use. Most companies wouldn't like to hire extra staff to just operate an AI platform. With our user-friendly interface, our users are able, even non-AI experts can build optimized AI model for the specific hardware. For example, one of our customers, a Fortune 500 company, was able to cut their model optimization process time from over a day to under an hour, which made a huge impact for their whole operation scale. In short, we focus on making high-performance AI viable at the edge in terms of practical, efficient, and easy to use.
Thank you, Soo-young. I think that it's absolutely correct that there are lots of different kinds of form factor and processor. So we can optimize on specific processor and architecture. That's one key to have the balance between the large language model and the edge devices. So let's dig more detail about your solution. So in your answer, you mentioned about a lot of video language model, the VLM model, and it's a multiple model, and we can with the modality including the video, the speech, or the language. So could you please share us what's the advantage and what's the benefit if we use these VLM models in your AI model and solutions?
Yeah, absolutely. So VLM is a new state-of-the-art model. It has a much better capability than traditional deep learning model based on CNN architecture. It is now able to understand scene and gives you insight based on the context. So we are aware that many other companies are also offering solutions based on VLM technology. However, there are three core principles that what makes us truly stand out from our competitors. First, we have developed the world's first. First, we have developed the most advanced AI model optimization techniques. While other companies are building solutions running on cloud computing, our solutions run entirely on local devices. Our solutions can not only handle up to 8 video channels simultaneously on a single edge device without requiring extra expensive GPU or high-end cloud computing center. That alone can cut deployment cost by more than 50%, which is a huge advantage to industries like manufacturing, energy, and transportation. Second, we've made our solution incredibly easy to deploy. Thanks to our collaboration with global partners such as Advantech, we are able to pre-integrate our solutions to their hardware platforms. So it allows users to just plug it in and start using it without need of any AI engineers or extra hardware. It is just as simple as installing a printer driver. And third, we have a real-world track record. What you offer isn't just a lab demo. What you offer is already commercialized in real-world environment across industries and across geographies. That hands-on experience allows us to learn from real-world challenges and apply the lessons to our products so that it makes sure to work on in practice. Besides, as everything runs on local devices, there's no risk of data privacy or any regulation issues, since anything sensitive never leaves the site. So in short, we're delivering high-performance AI, which is easy to deploy and privacy-conscious, and that vision AI system works in real world. Thank you.
Thanks, Soo-young. So let's go back to the real case in the factory. So we know that the AI AOI or the conventional AI model is installed in the factory for many years, and there are lots of applications that relies on the AI inspection. However, most of the case, the AI inspection will take a lot of training process, and lots of the training need to be implemented, or even at the cloud, or even at the HPC. So in the solution from Overview AI, it's mentioned about the edge training. So could you please share us what's the benefit or what's the feature if we adapt the edge training on the devices? Please, Xiao.
Yeah. So, like you said, AOI has been around for a very long time. Factories have existing visual inspection systems. The problem with existing AOIs are that they're very, very rigid. So they're very heavily reliant on the setup, on the lighting, on the part being the same. They're great if everything stays the same, but in a factory, nothing ever stays the same. So that's kind of the big issue that we've been seeing with AOI systems. What we're seeing now with edge learning is really like a huge step forward for manufacturing. Edge learning lets you adapt to the very dynamic environment that factories operate in. So you don't have to send data back to the cloud. You don't have to wait a week for your machine learning team to come back with a new model. With very few samples, training on the edge, that combination lets you really adapt really well to the practicalities of a factory. So, just to give an example, we were working with a customer in electronics manufacturing. They are inspecting for like really, really small welds on a electrical connector. There's 100 welds on a single connector. And everything was running really, really smoothly with their traditional AOI system until one day they changed their welding process upstream to make the weld better. But now the AOI was saying every part is bad. So how do you kind of match those two? The team was kind of stuck. They couldn't trust the system. They didn't have time to retrain data, collect new data. So what they actually did was hire a bunch of manual operators to inspect every single weld. So, there's a lot of impracticalities without edge learning. After they switched to our system, they added a few samples of new welds, and they were able to really just train it on the spot directly. And this is a workflow that they've really incorporated into their day-to-day workflows. So there's operators now in the factory that every day they go in and review the data. If it's inaccurate, they go in and retrain it. And this is a workflow that happens every single day on every line, should it be needed. So it's a very simple process, but deep learning and edge learning, training at the edge, is what really made it possible for AI to really be brought to all the factories.
Thank you, Xiao, to bring us the beyond the node solution, because most of the case that's not the edge training, but you bring us the other opportunity, another solution to have the edge training. So let's go to the last question about the future. So at Advantech, we are offering the vision AI solutions, and we work with partners and to offer the solution to the market and accelerate the time to market to deploy the AI solution by three approaches. One is to build from sensing, streaming, computing, graphics solution, and vision system to the customer. The other one is we built a good middleware. That middleware can help the operator or help the developer. They can deploy their software easily and reduce their learning curve. And the last one is build the strong eco partnership, not only for the silicon partner, but also for the SI and software partner. So then we go to the future. What did you think and foresee what will be happen in the future for the vision AI? Let's start from Xiao.
Yeah, so I think Vision AI is like very, very powerful right now. I think the problem that we've faced a lot when we go to our customers and work with them incorporating Vision AI is kind of a problem with trust. They need to be able to trust the system and really make that decision to remove the operator or incorporate it into their workflows or really believe in it to actually expand it. So, I think we do really see Vision AI becoming like a core part of people's workflows in a factory, from the manufacturing engineer to the quality engineer to the plant manager, even at the operation level. A lot of data from Vision AI can be used in a lot of ways to make things more efficient, make product better, make things just work better overall. But we believe the first step is to have people trust AI. When they believe in AI's decision-making process, then they can actually incorporate it as almost like a core team member where they can trust it and rely on it. And I think particularly for Vision AI, it's a big effort in explainability. Like I said, making models more explainable, being able to see why it made decisions that way is a very key step to making Vision AI more widespread.
Thanks, Xiao, to share us the future of the Vision AI. And how about you, So-young?
We also believe that AI is becoming more powerful, and it's not just about data or insights anymore. It's evolving beyond being just a tool, but being a decision-making partner. In the past, traditional machine vision systems were able to give you data or insights, but leaving the older decision-making part up to human beings. However, that's changing now. Just like how Jensen highlighted during his keynote earlier this week, with the rise of physical AI and new models like vision language models, is allowing users to commit a system where the model itself can not only give you the data, but also understand the scene, the context, and even take action if required. So for example, if an event occurs on site, the model is not just alerting you, it can really take in place and solve the problem for himself, adding values to more autonomy and more responsibility to the operations. And the oldest features and elements you mentioned in your question, we think that's really crucial to foster all this AI ecosystem and build what actually matters. So being a software company, we've often been asked how you're gonna scale without owning hardware stack. And our answer has always been simple. You succeed by collaborating with right partners. And we think Advantech is definitely, as being a global leader in this industrial computing area, we believe we can definitely create a great synergy to spearhead this on-device AI and Vision AI market with your extensive network. And that is why how we are collaborating with only top-tier companies such as ARM, Renesas, Samsung, and Qualcomm. And we believe that is why all those governments and local entities are trying to build AI ecosystem and foster this environment with all those dedicated strategies. For example, in Taiwanese government has just initiated Asia Silicon Base 3.0 with 5-year plan of, in numbers, it should be about 10 billion Taiwan dollars. And it proves that hardware layer, software, and rich ecosystem is a crucial keystone for building AI solution, which gives you extra value to the reality.
Thank you, thanks to Young, and thanks Xiao for the sharing us the Vision AI solution. And we truly believe that the Vision AI with the new technology will definitely transform the data to insight. So thanks for the audience, and stay tuned with the Advantech Insight Studio. Thank you.